Well, it's about 11 o'clock at night. If you saw the first video on this electric bike battery, you think, oh, we got a pretty good deal for 220 quid at the whole e-bike and the battery, because it's 26,650 cells. And for the most part, most of them are fine. Down here, they might not be. As you can see, there is quite a bit of water ingress into here. A lot of corrosion at the bottom of the pack. The BMS was totally destroyed. As you can see there, it's burnt a hole through the board where those resistors are. I promptly snipped the wire and taped the wire up because I didn't want that thing still connected, because of the resistance across that. It could short out, you know, it would get hot and then catch fire potentially. And someone's had this, I don't know how long they've had it sitting around for, but it's been a few days by the looks of it, since it got wet. It stopped working and they've tried to sell it on Facebook sales. So this has been sitting in someone's house or garage full of water. And I think if you left this long enough, there's a good chance that it would short out around here. Like, this hasn't broken down too badly, these are still pretty safe. This nickel strip's not coming into contact with any metal. So I think we've saved the cells. These for the most part, maybe that one down there is a bit suspect. I better be careful of that. But the BMS is totally destroyed and the battery is still outputting power. Still outputting 47 volts. And if I measure across the top here, I think this cell here is 4 volts. The others are like 3.5 volts, and one's like 3.7, and some are 3.8. But yeah, if I would have plugged this into a charger, had I had one compatible, this thing would have gone up in flames, because it would have hit. It would charge. The charger would be looking to see charged voltage, and it will just keep dumping power into it until the battery's full. And say if this cell's charging quicker than the rest of them, it could go over its 4.2 volt limit very quickly, and then the second they get over 4.2 volts, they start plating the anode with lithium, and then the whole thing is going to potentially explode. Pressure's going to build up inside the battery's going to blow its top. The temperature from one battery is going to set the next one off, then the next one, and the next one. Well, not battery, cell. I should use the correct terminology. Each of these is a cell. The battery is the whole thing built together. But if you get one cell failed, it's a thermal runaway, that will heat the next one up next to it, then that will heat the next one up, then the next one, and so on and so forth. And it will happen, so you get that one there go, then that one, and the one there, and then the whole, before you know it, you've got a very, very bad situation on your hands. Especially these being 26,650s, not 18,650s. This is an 18,650, an old Sanyo one. Let's put it on top there. Bit of a difference. And yes, it is dead. You can probably hear that it's like gone hard inside. It just heats up. You try and charge this cell, it'll just get hot. That's all it does. Or warm. Well, it doesn't even get hot, it just gets warm. That's totally dead. Anyway, that concludes this video on the nasty, rusty e-bike battery. Though quite a few of these cells are salvageable. That bottom one might not be. Some of these might be safe, we'll see. That concludes this video. See you later.